This is the YouTube video for the third lesson in the vectors unit from Aice 1, even though we're actually in Aice 2 right now. So the warm-up was basically a practice of what you were working on at the end of the last question. Last lesson where we had the house that had the roof on top and we had to find the angle between two vectors. So we're going to continue with that idea of the dot product, or as it refers to it here, a scalar product. So let's first of all look and see what information we've got on the question. So it says the diagram shows the roof of a house. The base of the roof, OABC, is rectangular and horizontal with OA equaling CB. So OA equals CB, which is kind of obvious if it says it's rectangular anyway. The top of the roof, DE, is 5 meters above the base, and D to E equals 6 meters. The sloping edges OD, CD, AE, and BE are all equal in length. Using vectors I and J, which are parallel to OA and OC, and the unit vector K, which is vertically upwards, express the vector OD in terms of I, J, and K. So what's important with this question is, as we're trying to get from O to D, we can't directly go from O to D because neither I, J, or K are in that direction. So we've got to try and work our way around the shape, but we can't quite do it as easily as we did last lesson where we just went like O to C, C to D, because we don't know how to get from C to D. So what we're going to try and do is look at all the individual components and see how many I's, how many J's, how many K's we need to do to get to that physical point D that we can see in the question. Now, looking at things that are parallel to each other, because that's going to be important for this question, I notice this is 14 and this is 6, which means I have an additional 8 meters, which would suggest that this overhangs 4 meters and this also overhangs 4 meters. So basically what I need to do is, first of all, I need to go this direction 4 units. So that would be for I. Now the next thing I need to do is look at my J component. Now it does say over here that this length here is 8 meters, so this must also be 8 meters. As the roof is in the middle of this shape here, then I know it must be half of this distance, so actually that must also be 4. Now I'm still on the base of the rectangle, and I know that's not easy to see on a 3-dimensional picture, but I'm now directly underneath the point D. So I just need to work out the height, and it did actually tell us the height in the question. It told us the roof is 5 meters above the base. So if I go upwards 5 units, then that should actually take me to the correct point. So while we're doing these questions, it is important to also look at the direction of these as well with vectors, because if they're going in the opposite direction, we've got to remember to give this a negative sign. So I've managed to express the vector in terms of I, J, and K. I wrote it as a column vector. Now I've got to find its magnitude. So from last lesson, to find the magnitude of a 3-dimensional vector, we just use 3-dimensional Pythagoras. So 4 squared plus 4 squared plus 5 squared. So I square each of the components and then I add them together. So 16, 16, and 25, which when I add them together gives me 57, and that's actually my first 4 points on this question. Use a scalar product to find the angle DOB. Now on questions like this, I always like to draw myself a little picture first. It doesn't need to be particularly accurate. DOB, so I'm trying to find this angle in here. Notice that to do that, what I need to know is OD, which is of course what I've just worked out, which is obviously why this is part 1 of this question, but I also need to work out what OB is as well. So that's my next thing I need to work on in this question. So let me get rid of that answer that we had a second ago. Now to get from O to B, I can just go straight along here because I know that this vector here is I, and then I can just go along that side because I know that that's parallel to this vector here. So it would be 14I. This is my J vector and its length 8. And actually, as this is on the ground, I don't need to go up any at all. So I found my 2 vectors that I'm actually looking for. Using my dot product formula, I noticed I've already worked out some of these things. Like I've already worked out the length of this vector. I do need to work out the length of this vector as well. So 14 squared plus 8 squared plus 0 squared should be square root of 260. 196 plus 64 plus 0. And the other part of the dot product, and I'm probably going to need a little bit more room for this one, is as we're doing this question, and I'm taking this directly from the formula sheet, is this formula here. Now I haven't actually worked out the dot product yet, but I deliberately wrote these next to each other to make it a little easier to work out. So I got 4 times 14, which is 56. I have 4 times 8, which which is 32. And then I got 5 times 0, which is 0. And the length of A I'd already worked out from the first part, that was square root of 57. And square root of 260 was the length of this vector. And that will give me cosine theta. And if we do inverse cosine, that will tell us actually what the angle is. And we just need to make sure that we're in degree mode. And then that should actually pick up our remaining 4 points. And that would give us our 8 points for this question. Probably on the exam, you should probably have around 10 minutes to do that. And we talk through this in just about 5 minutes.